Welcome guys, how are you doing? How's everything? In my last class on linear algebra, I've much more explained some certain particular things under system of linear equation, which we spoke about Gaussian law and Gauss-Jordan elimination method and everything like that. So I think we have some little, misconceptions about Crammers law, or we say Crammers rule or Crammers law. Any of the one you want to say, we usually can just say rule, make it much more easier. So when we talk about grammars, we also one of a certain particular rule that can help to solve simultaneous linear equation effectively and perfectly. But I told you guys the limitation is that the limitation between all these rules, your Crammers rule, your matrix rule, your cofactors and all those ones that they can't solve a lot series. It will make it much more it will give you a certain issue when it comes to dealing with series of what do they call it? System of linear equation. Talking about like 7 or 5. So it's much more easier to implement the Gaussian, the Gauss-Jordan to literally get your answer easily. Alright, so when we talk about Crammers, these are the laws that we literally need to solve any questions under it. And as we know that much more of a system of linear equation, we can put it in a matrix form, which we have A being the matrix, the coefficient of the, what do they call it, of the values of the variable, dot the x. Now we can use x, we can use y, depends on what we needed. What we need actually equals to what? B. This is the result, the answer. These are the coefficients of what? Of the variable. So, but nevertheless, when you have a certain particular equation like this, majorly the three equation is simultaneous equation. The first step is that you arrange it in the matrix form. And what are the matrix form? You put them in, at times you call it in a well simplified and experienced linear algebra. We call it the adjunct, the adjacent, adjacent. So at that point, but just let us make it easier for ourselves so as we don't have any issue. So you bring them out separately. This is the function we have. So in this point, we are going to put it in terms of matrix form, a rectangular part. So you have this as this as this as this. So at that point, some of you might wonder, how is 6? 6 is x, 4 is x, and it's no, that is not how we categorize it. We categorize it in terms of its rectangular and vertical form. So these are the answers we have. So the first thing is arrange it in matrix form. And the second thing is that you now find the determinant of the problem matrix. So this is what we call the problem matrix. We can call it A. So this is A, this is dot the variable. You can call the variable S. What I'm using is that you can have at times you can have x1, x2, and x3. But this is why we are using diverse variable here. So that's why I don't want to implement it that way. So find the problem matrix by find the determinant of the problem matrix, and this is the determinant of the function we are looking for. So then after the step 2, you move to step 3 by solving for the values, which is the x, y, z. Now, how do you solve for the value? This is the most crucial part of that. You replace each value you are dealing with. Now, if you look at now this part, so if you are looking for x, you will erase any family or relative of s. You can say pound in right, so f pound in right. Then from there you literally erase everything. You now replace it with the solution, the answer you have for the simultaneous equation. So that's what I'm talking about here. So you erase the family of x, then you replace it with the answer we have, which is this. So this is 5, not 3. It's 5. So the answer we have in the simultaneous equation. Are we there? So the same thing goes to here also. Since is y, we erase the family of y and replace it with the solution we have in the simultaneous equation. And the same thing goes to z. Now if you look at this question, you see that they are actually the same thing. They are using Crammers rule. And what's our first step? Our first step says that what? The step 1. Like I said now, the step 1 we have to talk about is arrange them in matrix form. Now if you look at something about this one is that at this point you see you have x3, x3, x3. You have x2, 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 x1, x1, x1. We don't use x, y, z here, so it's still the same thing. And don't be a one-man protocol. You follow only a single protocol in life, you might literally not get to your journey faster. So literally x1, x2, x is also the same thing. And we are going to be utilizing that. Now, first of all is what? The matrix form. We have 3, we have -4, we have 8, then we have 6, we have 3, and then we have -5. Then from there we have -2, we have 1, because the end of x2 here is 1, there's an simple 1 here. Then we have 3, then from there we have this being equals to, what do they call it? We have this being equals to, okay, before the equals to the coefficient, the variable. So now this one, instead of saying x, y, this will be x1, x2, and x3. So nothing changes, still the same thing. Then our solution, we have 26, we have 1, and we have 11. out there. So that is one thing we need to note first and foremost, that we need to understand about the concept of that. Then that is step one. Then step two tells us that what? You find the determinant. So let's say that this is A. So you find the determinant of the matrix A. Determinant of matrix A, which is equals to determinant of 3 minus 4, 8. Out there, guys. 6, 3 minus 5, minus 2, 1, and 3. And when I say determinant, we know that this is related to 3 by 3 matrix. And to find the determinant of 3 by 3 matrix is very simple. What do we do is, it's just like a little step of this, but this one is like whenever you are killing a column, you kill the column, you now look for the edge. The edge is, I can call it diagonal. Now you kill column, you kill row. Now, first and foremost, now we want to eliminate. We eliminate the first column, first row. Second column, first row. Third column, first row. So it's only the column that changes, but the row doesn't change. Now, what do we mean by that? If you have to look at now, eliminating this from here, I don't want to use my hand to, I don't want to cancel it. So if you have to eliminate from here and here, we are left with what? 3 minus 5, 1, 3, right? And if you look at now, the diagonal, the point at which they all meet is what? 3. And whenever you are assigning points, you have something we call the, what do they call it, minus 1 is for I plus j. So I in terms of row, j in terms of column. That is how we assign the sign that we usually use. Yeah, okay. So, but we literally don't have time for that. Let me just put it that way. We're not going to be dealing with that in that way. So, but we know that practically whenever you're starting, you don't know determinants, you need to go and check in my videos. I've explained determinant there already. So, at this point, the first sign takes positive. And when they meet, they all meet at 3. Then you now find the determinant of those smallest one we abandon. From here to here, we abandon 3, minus 5, 1, and 3. The second thing is the next sign it takes is negative. Then let's look at now, second column, still the first row. Where do they all meet together? At the middle point here, which is what? Minus. Now, you know you have minus before. This is minus 4. Please don't make that kind of mistake or that kind of error. So we look at this, then we spare 6, minus 5, minus 2, and 3. Then, from there, the last part now, we have positive. So it's positive, negative, positive. So, from that point, like we have said, we have plus. And the next thing now, we eliminate the third column, but still at the first row. Where do they all coincide? Where do they all meet? They meet at 8. So we have plus 8. Then we now find the matrix of those ones we literally spare. And we find the determinant of those ones we spare rather. So you have 6, 3, minus 2, 1. So then from here we find determinants. We don't need to stress ourselves. So the term this will be equals to, this will be equals to, this will be 3 into brackets. Now we know how to find determinant of the smaller ones now, 2 by 2 matrix. 3 times 3, you have 9. Minus into brackets, 1 times minus 5, you have minus what? Minus 5. If you don't know how to do this, you have a big issue. Not only this little issue, family issue. You don't know how to do this, and you are coming to learn Crammers. Oh, yeah, okay, maybe. Minus times minus, this is plus 4. And from here we have this. Then this will be 6 times 3, that gives us 18. Then minus into brackets, this will give us minus 2 times 5, that will give us 10. So practically we can just say 18 minus 10. So as not to make the journey that long. Are we there, guys? Then plus 8. Then this is 6 times 1, we have 6, right? Minus 2 times 3, you have what? Minus 6. I just want to break it down for some of us because most students nowadays, any little step that we skip, they find it difficult to even understand, even though it's 1 plus 1 we skip. So at that point, you have 3, then we have this. This will be 9. Minus times minus, you have plus, so be 9 plus 5. Then plus, so we have 4 into bracket. 18 minus 10, you have 8. Then we have plus 8 into bracket. This is what? Minus times minus, you have plus. Then 6 plus 6, that gives us 12. So as to make everything much more of an error-free. So I hope you know how we got this 9 plus 5, right? So 9 plus 5 gives us what? That will be 14. So as to not 3 times 14, that gives us 42. And plus, so you have 4 times 8, and that gives us 32. And then you have 8 times what? Times 12, and that gives us 26. So literally, this plus 32 and plus 42. That gives us 170. Which means our determinant is what? 170. So that's the first part I want us to understand under the conceptual knowledge, and that is step 2. So from there, we'll talk about this. And what is our step 3? We've gotten our determinant. So step 3 is that what? We now what? We solve for x, y, and z by replacing each of what? The empty column. Right, guys? Now if you look at now, the x1 is equals to the determinant of our result is what by the answer of what we have. So which is 26, 1, 11. So we replace it because the first point is the x1. So 26, 1, 11. Then we now continue with the normal variable minus 4, 3, then 1. And we have 8 minus 5. And we have 3. Then divided by the determinant of what we have. The determinant of what we have. And what's the determinant of what we have? 170. Are we there, guys? So which means that at this point, for us to get any result, we have to find the matrix of this one. Can you see it's not an easy job? So finding the determinant of this rather, Jerry. So find the determinant of 26, 1, 11, minus 4, 3, 1, 8 minus 5, 3. So that will be equals to, that will be equivalent to, I've explained that already, so we're going to stress ourselves again. We have 26. So at this point, we have 3 minus 5, 1, 3. And the next thing we have minus, into bracket minus 4. Then we have 1, minus 5, 11, 3. Then we have plus, the next part like that, we have 8. Then from there we have 1, we have 3, we have 11, we have 1. I'm trying to break it down much more easier for us. We don't need any long method, we don't need any shortcut, so just normal process for you to understand the basic necessity. So this will be 3 times 3, you have 9. This will be minus into bracket 1 times minus 5, you have minus 5, which will become 9 plus 5. Right? Then plus 4 into bracket 1 times 3, you have 3. Minus into bracket minus 55. This will become what? Plus 55. Then plus 8 into bracket 1 times 1, 1 minus 33. So at that point we have this to be equal to 26 into bracket 14 plus 4 into bracket 58 plus 8 into bracket minus 32. And that gives us 364. And 4 times 58, that gives us 232. Then minus, because plus times minus, we have minus 8 times 32, that gives us 256. So minus 256 plus 364, then plus 232, and that is equivalent to 340, which is our answer for what? X1. Are we there? So you can put it somewhere here. Now let's just move on to the next step. So let's go to the next step. Then from there now move on to, so this is our X1. And let's just get the final answer practically. You know, this is what we just find. So from there we have our H1 being equals to, what's the result of the determinant? Determinant is what? 340. That will be 340 divided by, what's the determinant generally for the simultaneous equation? 170. So that will be equivalent to 34 over 17. So that will be our answer for that, which will be equals to 2. The next one now, move on to x2. Now x2 will be equivalent to what? We literally need the first part, which is 362. 3, 6 minus 2. Then the middle part is what we are going to ignore because that's the second column. So we are ignoring it by putting the solution now. So that will be 26. Then we have 1 and we have 11. Then we will put the normal part, which is 8. We have minus 5. We have 3 divided by terminal. Can you see how fun it is? How fun it is dealing with this question. So let's move on from the process here. Finding determinants, right? Determinants will be equals to, we have 3, then into brackets. You know it's like this, we have 1, we have 1 minus 5, 11, 3, then minus, that will be 26. You have 6, minus 5, minus 2, 3. The next one, you have 8, and that will be what? 6, 1, minus 2, 11. So in a nutshell, we have this being equals to 3 into bracket 1 times 3, 3, minus that will be plus 55 out there. So then you have minus 26 into bracket. Now, from there you have 18 plus 18 minus further, minus times minus plus, so 5 times 2, 10. Then plus 8 into bracket. This times 11 we have 66. Minus, this minus 2 times 1 is minus, so that will become plus 2. You can count down, but this is a baby work. The determinant is the baby aspect of work if you've worked with it before. So that will be equals to 3 into bracket 58 minus 26 into bracket 10, 8 plus 8 into bracket 68. So which means our determinant now, determinant will be equals to, so 58 times 3 we have that to be 174 minus 26 times 8, that gives us 208 plus 8 times 68, and that gives us 544. So that will be 544 minus 28 and plus 174. So that gives us 510. This is the determinant for this particular work. This one is what? 510 divided by what? 170. So that should give us K. So that will give us K. We said 340 divided by 170, and that gives us what? 2. So that is the sum for the second aspect of it. Then move on to then move into x3. They have x3 being equals to. So we write the normal one down, minus 2, then minus 4, 3 and 1. Then we replace with the answer 26, 1 and 11. Then from there, the determinant we get generally, which is what? 170. Then from here, we find the determinant of what is up there. This will be 3 into bracket what? So we have this. There will be 3, 1, 1, 11. Then minus, then when you have minus 2 bracket minus 4, that will be plus 4. Then you have this. Then from here, what do we have practically? We have this. Then you have 6, 1, minus 2, 11. Then 26, that will be plus 26. Then from there, you have what? 6, 3, minus 2, 1. Then from there, the determinant will be equal to 3 into bracket 33, minus 1, plus 4, 66, plus 2, plus 26, 6, plus 6. This is equals to 3 into bracket 32, plus 4 into bracket 68, plus 26 into bracket 12. So from there we have this 32 times 3, that gives us 26, plus 68 times 4, that gives us 272, then plus 26 times 12, that gives us 312. So 312 plus 372 plus 96, that will be 680. So therefore, that will be equal to 680 divided by what? 170. And answer divided by 170, that should give us 4. Which means our x1 now from the related answer, our x1 is 2. Our x2 is 3. And our x3 is 4. So you can cross-check your answers. Why I love some of those equations is that you can easily cross-check your answer to see if you are wrong or correct. Let's use this equation to cross-check our answer to see if it results to 26. Now that will be 3 into bracket. What's our x1? Our x1 is 2, right? Then minus 4 into bracket. What's our x2? Our x2 is 3. Then plus 8 into bracket. What's our x3? Our x3 is 4. So let's see. 3 times 2 you have 6 minus 12 plus what? 8 times 4, that gives us what? That should be 32. I lost this on total. I beg. So that because we don't want any error or mistake. So from here 32 plus 6, that gives us what? 38. Then from there 38 minus 12 you have what? 26. So you can usually see that what is actually correct. So that is just literally all about Crammers. And whenever I will even urge you, only if you have a certain particular question, only if they enforce it on you that use Crammers rule. If you have a simultaneous equation that involves 3 equations, you can use your Crammers rule, still okay, still preferable. But when you have more than 3 equations, you're having 4 or 5, I will urge you to use the Gaussian elimination method or the Gaussian elimination method. Only whenever you are being asked to make sure you see certain particular method in a question, so you must not skip it or use another alternative method. You make sure you use that method you have been given, even though it's a long method. That is what the examiner or the marker wants. So that is what you should use. Thank you. I still remain your humble host, the bad boy of mathematics, Dr. Quanta.